Uh, okay, well, thanks for having me today. I was asked if I could do kind of a basics introduction to solar electricity. And so for some of you, some of this will be really basic. I'm going to throw in a few technical nuggets for those who are a little more advanced in the subject. And again, as we go, feel free to ask questions. We'll try to keep up with them real time so we don't get too far down. And if you ask about something that's coming up, I'll just say it's coming up shortly. So with that, I will get us rolling here. I plan to talk just a little bit about what is solar photovoltaic. That's the official name, and everybody uses PV, as you can see, because it's much easier to say. I'm going to break down and talk about the system components, and then we'll talk about how do you size one, how do you decide how big a system you need, and then a few things about how to optimize the system. And then the piece everybody's always interested in is the financial pieces. And then I put solar on my own home. We have a passive solar house, but I put active PV panels on the house in 2012. So I'll just give a little case study that'll hopefully tie all the stuff we've talked about together so you can see how it works in the real application. So very basically, a solar PV panel produces electricity from sunlight. And the simplest explanation is photons from the sun, which is sunlight, knock electrons out of an atom, and they have to end up traveling through a circuit to get back and restore that electrical balance. That's, in its simplest form, you're using a photon of light to displace an electron, which flows through a circuit, and that's what electricity is electrons flowing through wires. So on its most basic level, that's how they work. It's pretty interesting. People think of it as fairly new, but the first effect of light producing energy was noted in France in 1839. And there were observations during the 1800s in France, and there was some work with selenium-based solar cells back in the 1800s. And some guy named Einstein, who had his hand in a lot of stuff, published a paper on photoelectricity in 1905. But it really didn't, I guess, catch attention until the 50s when the silicon-based solar cell was invented at Bell Laboratories. Then they became popular in space satellites initially. They were very high cost, but they also, when you're in space, you can aim at the sun all the time. So it was the best source of energy for satellites. When the US had oil embargoes in the 70s, interest began and the Department of Energy was formed. They started putting some money into research and development, and that began to drive the costs down. And then it's probably sometime around 2012, which is when I decided to put some up. Production volume got high enough that the price became palatable for most people. And now today it's cheaper than almost every fossil fuel based energy source. So a lot of history, but it's interesting to see how long it's taken to get to the point that we are. So there are variations in sizes, but this is the vast majority of solar panels. If you look at the two on the left, those are panels, and they're roughly 39 inches wide by 65 inches long. There's two different types. The one on the left is a polycrystalline, the one on the right is a monocrystalline. It really just has to do with the way the silicon is processed. Polycrystalline on the left has generally been lower cost, but it's been lower efficiency. It's about 29% of the market share right now, and it's falling because the one in the middle, a monocrystalline, has more efficiency, and that's been improving quite rapidly, has the longest life. It's higher cost initially, but that's often offset by the efficiency. You might need fewer panels, and because each one is going to produce more energy. And it's at 65% of the market share and actually growing. The third type, which is a small percent of the market right now, but there's an awful lot of activity in various material science classes going on for thin film type panels. You can see they could be made flexible. They're kind of almost like printed, mass printed. So those are three different types, and you'll see them rated at the top. You see I have 180 watts, 240 watts, 300 watts. That will be the DC power rating of a panel. So DC, I just mentioned, that's direct current. if you have a AA battery, that produces direct current. It has a positive terminal and a negative terminal. So photovoltaic panels, PV panels, make energy in direct current. Batteries also use direct current. But in your house, almost every appliance you have plugs into the wall, and that is alternating current. And that's the transmission, all the transmission lines, all of our electrical distribution system is in alternating current. So how do you get from direct current to alternating? There's a device called an inverter. And that will both turn DC into AC and then also synchronize with the electrical grid. You can't put a waveform onto the grid that's not in sync with it. So these inverters have a few different functions. So there are 3 different types of inverters, and one is on the left is the string inverter, and it's called a string because you basically string all your panels together in DC, bring that into the inverter, and then it does the AC conversion and synchronization to your house. I'll flip over to the one on the right, and that's a micro inverter, and it's a small inverter that attaches to the back of every solar panel. There's a hybrid in the middle where you use a string inverter and then attached to every solar panel is a DC optimizer. And now I'll talk about the differences, pluses and minuses between the different systems. There's not one that's right or wrong. They're really just kind of depending on your application, it would be the one you want to use. The advantage of the string is there's no electronics on the roof. It's usually down in a garage or maybe in the side of the house. You're running all of the electricity in DC already, so it's easier to connect batteries up if you want to use batteries. And it generally has had the lower cost per watt of energy. Its big downside is it doesn't optimize each panel. It runs the wires in DC, which fewer electricians are familiar with DC wiring than AC wiring. And it's a single point of failure. If your inverter goes down, all of your panels are offline. The microinverter, flip to the other side, that one optimizes each panel's output. It runs the wiring in AC, which all electricians are very familiar with the codes, and it gives you panel level monitoring on your system. You can look and see how every panel is operating. It's harder to integrate batteries, and it's a little more expensive per watt. Now, why would you want to optimize each panel? Well, if you have a string inverter and you have, say, 20 panels on your roof, and one of them's kind of near a tree and it gets shaded in the late afternoon, when you have them all together, they can only operate at the lowest common denominator. So if one of your panels has a manufacturing defect and is a little bit weaker than the others, or it's got shading, it will drag the whole system down. Whereas the microinverter, it optimizes every single one. So the shaded panel, its output is down, but every other panel is still producing at full power. And that's what happens when you use the DC optimizers, is it will do that optimization in DC and keep every panel operating at its peak. So I see a question coming in. I'll try to take them real time. What solar inverters do you recommend for a small condo? Condo, that'll be interesting because you have all your association to deal with. But if you can get the approval to do panels, either one is probably fine. If you have a fully sunny space where there's not really any shading characteristics, a string inverter would be fine. A string inverter with DC optimizers might not buy you much if the panels are all well matched. I personally use the micro inverters, and I'm happy with those. I think when you're looking for a system, you'll get bids, and suppliers will kind of have their favorites and why. And really it kind of just comes down to, as you'll see when I talk about costs, it just comes down to who's giving you the best value in dollars per watt. Now, a couple of technical terms. So there's power and energy, and these get interchanged way too often. Panels and inverters will be rated by their power. It'll be in watts or in kilowatts. A kilowatt is just 1,000 watts. How much energy something uses is stated in kilowatt hours. And that's what you get billed for. When you get your electric bill, if you open it up, it may say you use 700 kilowatt hours this month. And that is 1,000 watts running per hour is a kilowatt hour. So an example, if your TV was a big TV drawing 150 watts and you watched it for 10 hours one day, you would have used 1.5 kilowatt hours. If your electric rate was 10 cents a kilowatt hour, you didn't spend too much money to watch that TV for the day, but over the course of a month, it can add up. Now, how do you mount these? Well, there are several approaches. Roof mounted will often use some screws into the shingles, some waterproofing, and then rails are put on top, and the panels are mounted on the rails. Ground mounted systems will have poles in the ground with these rails mounted on those. If you have maybe a flat commercial roof, there's ballast mounted, and that way they could be easily removed if you ever need to re-roof. So they'll use like a cinder block or concrete block for weight to keep the wind from picking them up, and then a little framing system. And then most recently, we started seeing Tesla being the most famous, the solar roof, where they actually make the shingles out of solar panels. And so instead of buying a roof and a solar system, you just buy one that does both. So I'm going to put a couple of schematics here just to kind of show you. This would be a string inverter, a central string inverter. All your PV panels would be there, would be run in DC wiring. You could optionally have optimizers, it's a tongue twister, on each panel. This would be if you wanted to use batteries for storage. You could use a charge controller, and the PV panels could go directly to the batteries, and then the batteries could feed the inverter. And then here's your load, your house energy, and you've got a meter on the side of your house, and that's connected to the grid. What I have is the microinverter. So every panel has a small inverter on it. This is AC wiring, goes to the house and the load, and again, we have the meter and the grid. It's a distributed point of failure, which is nice. If one of my microinverters goes offline, the rest of the system continues operating. Now, net metering is a key term you'll hear, and I just put some sort of generic system, and here's all your loads in your house, and you might have an electric vehicle, and there's your electric panel. You've got a smart meter on your house, and this meter can spin in either direction. So during a sunny day, in fact, at my house here today, it's cool, so we're not running the air conditioning. I can go outside and my meter is spinning backwards. I'm actually feeding my solar powered electrons back into the grid, and they're going into my neighbor's home. And so I'm getting credit for that. The meter's rolling backwards. And that's a key piece, and we'll talk a little bit more about that in the financial section. So I mentioned the cost drop. In the 70s, panels, you'll see people talk about dollars per watt. So if you have a 300 watt panel and it costs $300, that's $1 per watt. It costs $150, that's 50 cents per watt. So back in the 70s, when they were just going on satellites, they were $76.67 per watt. And a lot of R&D went in, and the price came down, 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 down. And then it kind of, meandered along for a while. And then suddenly volume production started kicking in with some government incentives you can see this around 2009, 2010. And then the momentum just kept building. Now, 20 years ago, if you wanted to put in a whole solar system with all the components, the panels were at least half of the cost. There's inverters and the racking and the wire and the labor and profit and all those other things. But this was the main piece. Well, today, the systems are cheaper. 75% of the cost is gone because everything's gotten cheaper. But you can see the cost is very distributed now. The PV panels are no longer the driver of the system. It's all of they call balance of system, all of the rack and the wire and your permitting and the inverters and marketing and sales from the company. So it's been interesting to see the shift. Here's what a 2020 cost looked like. Panels, profit. It's all very well distributed, and there are many people working on every slice of that to keep driving the costs down if they can. So how do you size a system? Well, I'm a big efficiency proponent, and I want to say efficiency first. Make sure your home or business has addressed energy efficiency, because that way you'll need a smaller solar system to cover your needs. You don't want to waste energy in any form. Also, many efficiency projects have a faster payback than solar PV does. Even with the current price drops, there are efficiency projects that can often pay you back in a year or two. One strategy is to go ahead and add a small solar system and continue to work on efficiency so that initially maybe your solar system is covering 30% of your needs. So it's still reducing your bill, but as you continue to improve efficiency, that climbs to 40% or 50% or 60%. So that's an alternate way to approach it, is in parallel.
Paul?
Yes.
We had a question, and I had to step away for just 1 minute. So if you've already answered this, my apologies. But the question is, what solar inverters do you recommend for a small condo? And since you were talking about small houses there, I thought this was a good time to insert that question.
I saw that one pop in while you were away, and we already got it covered, and I'll cover a little bit more of it here in a bit. But any of them work. It depends on your installer's comfort level. They're all good paths. They're just different. So how do you size a system? Well, the best thing is if you've got utility history, you can review your past utility bills and you understand the usage. And I went and did some research and found kind of a typical North Texas energy use is January through December, and the left axis is kilowatt hours per month. And as you can see, certainly if it's an all-electric home, you're going to have higher use in January. It'll start declining in February, March, and April are pleasant months. Then the summer climb commences. August is usually the worst bill, July and August. Then you get a little breather again in the fall, and then it starts climbing. But if you understand your bill and your usage, that's a very good first step. Then the key is all of the utilities have different policies. I'm in a co-op. I'm in Grayson Electric Co-op. They have their own completely different policy from any other either co-op or large commercial utility. So you really need to understand what their policy is. And the question is, what is their net metering policy and how do they handle it if you make more energy than you use? That's a really key point. It can really determine the financial payback differences of a system. So most systems are sized to produce not 100% of your load, but some portion, or in some cases match the lowest monthly load. So for instance, when I installed my system, Grayson Collin would not credit me or pay me if I sent excess. So if I put in too many panels, I would be spending my capital cost and giving them free energy during the fall and the spring uncompensated. So that doesn't make good financial sense for me. So I looked at my bills, and as you'll see when I do my case study, I sized it to meet the lowest uses, and then it just trimmed my bill on the other months. Your size might be limited by how much sunny roof area you have, but there's a great free tool that probably every company uses and any individual can use called PV Watts. And National Renewable Energy Labs developed this. And this would be an output. So I went to the PV Watts tool, and you can go there. You can Google PV Watt, or I've got the link in here in this presentation. And you can input your location. I'm going to put 5 kilowatt system, just for the example. I'm going to face it due south. That's 180 azimuth. I'm going to angle it 33 degrees with respect to the horizon. And I'm going to put my rate in as 10 cents a kilowatt hour. These are just to run the system. So now it gives me the output of how much electrical energy, after it does the DC to AC conversion, I can expect each month with a system of that size. And based on my rate, here's the savings that I would get. So you can see I'm producing 7,644 kilowatt hours. Well, look at the months. It's fairly low here in December, 532, and pretty high up here in August, 731, when we're very sunny. But this is a great tool, and it's free. So optimizing the system, I'll pause here and make sure there's no other questions coming in. So let's talk about how do you optimize. You may have noticed this or not paid much attention to it, but it's pretty interesting. If you pay attention to the sun's path across the sky, it's extremely variable during the year. Just a couple weeks ago, we had the equinox, and if you happen to go outside near sunrise or sunset, the sun was rising due east and setting due west and arcing fairly high up in the sky. If you go back out in December 21st at the solstice, the sun is going to actually rise fairly far south of due east, stay low across the sky, only get up here to 33 degrees above the horizon, and set fairly far south of the west. The summer, it actually rises north of east, goes very high in the sky, almost directly overhead, and then sets a little bit north of due west. Now, if you know the path, then it's pretty obvious that you want a south-facing roof surface and maybe tilt it up about at your latitude to really optimize your energy use. And if you're roughly optimized, then every kilowatt of panel you have produces about 1,400 kilowatt hours every year in the Dallas-Fort Worth area. So now let's get to the part everybody loves, the money. So for an example of that 5 kilowatt system, that would be roughly 16 to 20 panels, depending on the wattage of each one. I've been seeing prices down below $3 a watt in our area. Not all the time, but if you have a good location, easy access to the electrical panel, I've seen prices down even lower than this in a couple cases. But let's just say $2.70 a watt is what your provider quotes. That would be $13,500. There are some utilities that have incentives. If you're in the Encore distribution area, they usually have an incentive every year. The money runs out, so you have to apply quickly. I didn't have any incentive in Grayson Collin, so I just left that blank. The federal tax credit, and I'll show you how this is actually declining. This year for 2020, it's 26%. So if you put in that system at the end of the year, you actually get a credit. It's not a deduction, it's a full credit. If you're at least paying enough taxes to get that credit, then you're going to save $3,500 on your taxes. So that ends up making the final net cost of that system just under $10,000, or right at $2 a watt. Now, if you assume that the system's going to last 25 years, you can calculate that you've basically just bought your electricity output for 25 years at about 5.7 cents per kilowatt hour, probably less than your utility is charging you. If you're looking, I've got some links on here. Again, I'll have this presentation available. It's on PDF. It's on my website already. You can go look and see for your area, are there utility incentives for my area? There's a link for that. And there's also a nice link down here for the deregulated areas, which are areas that aren't in a municipality or co-op, which is most of the state. Some of their net metering plans are already listed in there to save you a little bit of searching. Now, the federal solar tax credit I mentioned, for a number of years, and back when I installed mine, it was 30%, and it stayed there for a long time. This year, it started ratcheting down. It's 26%. If you wait till 2021, it's 22, and then for residential, it will disappear after next year unless they renew it. There's a 10% one for commercial systems, but residential will go away. So if you've been thinking about solar, you might want to think a little faster, because there's no telling what will happen with this. Absolutely no telling. Now comes the big question is, and this is a very personal issue, but I wanted to show you the options, and for each person, your best answer will probably be different. So say you got a quote that you like and you think this is going to save us some money, we want to go solar. Easiest is flat out purchase. If you have money in the bank and it's earning 0.5% interest right now, the basically return on investment for solar is about 8%. So to me, this is how I did my system. I paid cash because over the 25 years, that's basically given me a really nice guaranteed return. If you could find a favorable loan term, that might be a way. Many of the solar panel providers have leasing options or financing options. And there's also even more complex as a power purchase agreement, where you basically agree to buy the energy that the system produces over time. So the lower ones, there's no money out of pocket, but you're not reaping all of the benefits. You're sharing some of those benefits with the company, but still it might be the right choice for you if you don't have the cash to invest. But really, if you're talking to a company, I put them in red because there's really three things that you want to make sure you know. How much electricity do you use on an annual or monthly basis? So remember my monthly chart. You really need to know that for your average use for your house. Then you get a bid. What's the net dollars per watt for the solar installed? So after the federal tax credit and after any rebates, here's my net dollars per watt. And my example had $2 as the net one. And then of that system I'm putting in, how many kilowatt hours am I going to get? So you can see how much of your energy it's going to offset. And then that purchase, borrow, lease, that's a personal decision. But I actually stole this from Larry Howe, who gives solar basic presentations a lot. He says, remember, financing and leasing companies are like any other one. They're offering those so that they can make money too. In some cases, it's a win-win, but just be cautious and read the fine print. That's what I will tell you. So let's talk about payback. Here's a little quiz. This is a pop quiz. We're not going to do it as a poll, but what's the payback of any of the following? Crown molding with the British spelling, the fancy molding you might put up at the top of your wall and ceiling joint, a fancy $12,000 coat, solar PV, a giant SUV, which, $85,000 and is very low rated on Consumer Reports, stainless steel high-end appliances, or buying fancy coffee at a coffee shop. What's the payback of any of those? Well, nobody ever asks about any of, they only ask about solar PV when in fact of all of these things, it's the only one that actually has a payback. And if you do an internal rate of return, an IRR calculation on a 25-year PV system, it's returning around 8%. It may have a simple payback of 10 years, which may sound like, well, I'm not going to do that. But after that, there's 15 years of making profit for you. So it's got a long-term guaranteed return. The stock market may return 8% one year, but it may take that back the next year. The solar is going to be consistently paying you back. So I'll take another pause here and then we'll go to the case study and you can see the details on my system and that'll help kind of wrap everything up here. If there's any other questions, you want to type them in or? Okay, I'll keep an eye on it if anyone comes in. So this is my house we built back in 1996, just turned 24 years old last month. The passive features are kind of shown in here, and you can see it's a compact floor plan, 2-story. Most of my windows are on the south with overhang, so I did everything I could. I used structural insulated panels, I insulated the slab perimeter, I used a metal roof that was reflective, I used solar water heating to heat our hot water, or heat our water, then it becomes hot water. I did all those things to minimize how much energy we use. That's just a list of the features. So we're about 80% more energy and water efficient than a typical North Texas home. So we have a real running jump start in the first place. All right, I just see a question come in. Good explanation for IRR, thank you. What's the minimum number of years to be in a house that would make this profitable? So if you get a quote on solar and you're around net $2 per watt, it may end up looking like a simple 8 to 10 year payback. And that does sound long, but if you're going to be in the house for a while, it's good. Now, there's another advantage that I'm not even sure I put in the slides. All of the taxing entities, the state of Texas did a poor job of rolling this out, but every county taxing district will give you the value of your solar is not taxable. So you can have an appraised value, and they all do it differently. I wish it was more consistent. But basically, the value of your house will be this, and then they will take off the $10,000 of your solar system, and you'll only be taxed on the lower amount. So if you're selling your home, even if you're going to move and sell it, there is a value to that you can convey to the buyers that one, they're going to have lower energy bills, and two, it's actually reduced, it didn't increase their taxes to have that. So it's a tax exempt asset on the house. And you'd have to go to your own county website, and they often seem very confused by it. I don't know that many people claim it. I've been claiming it for many years since they since Texas introduced it. And the first year I worked with a guy for probably 6 hours trying to help him understand solar, because I was the first one he was doing and he had no idea what it all meant. So hopefully they're a little more sophisticated now. So here, remember my home energy use graph earlier of a typical North Texas house? Well, the red lines are my energy use, and my company didn't offer anything. So I said, I'm going to target my monthly productions. I'm going to look in the spring and the fall, and I'm going to see if my, target the size of my system so that I'm producing about that amount. And then it'll just obviously trim my summer and winter bills down. So you can see that 440 kilowatt hours was my fall and spring target, and I ended up with a 3.7 kilowatt system. I have 14 240 watt panels and 270 watt panels. And the reason that I have a mix of panels is I bought these off Craigslist. They were B grade panels, which mean they had a cosmetic defect, but they tested out just fine. And I did most of the installation myself. And so 2012 prices weren't as low as they were now, and this was one of my strategies to get the cost of my system down. And it still covers about 75% of our annual energy use, even with that optimizing for spring and fall. So I see another question come in. I'll get that one in just a second. So here's my actual numbers. I spent about $7,500, which was $2.03 per watt, because I did most of the installation myself. The tax credit, I got a $22.50 tax credit. So my net was about $5,250. So $1.42 a watt. That made my effective 25-year energy cost 4.1 cents per kilowatt hour, whereas my utilities charging around 11. If you add up my savings over 7.7 years, I'm at 4,300. So I haven't reached payback. If you look at simple payback, I haven't reached the 5,200 yet. But again, my money is basically earning an 8% return for me since I put it into solar, and will continue to do that for years and years and years ahead. So let me pause here. There's a couple questions coming in. So this is the question about, what if you have to install them on a different face? Well, the beauty of the PV Watts tool is you can go in there and actually run different scenarios and say, what if I put them on the west side? And you'll see the output. What if I put them on the east side? You'll see the output. What if I put them on the south side? What if I'm 15 degrees off of due south? North is not good. Definitely don't want north. In general, if you're roughly south plus or minus 15 degrees, it's really imperceptibly small penalty. West is not bad if your utility rates charge you for peak hours and stuff, because you'll be getting peak sun on the west side at your highest use time when you're likely running your air conditioner the hardest in the summer. But the PV Watts tool will allow you to do what ifs and see how much reduction you get from various faces. So question about week of cloudy skies. Well, I'm not on batteries. Most solar systems are not on batteries. We're mostly grid tied. And so I think of the grid as my giant battery, is basically what it is. If it's cloudy, I'm producing less energy. It's not zero, but it's less. And so I'm drawing a little bit more from the grid. On a sunny day, I'm spinning my meter backwards, sending energy to the grid. So unless you were trying to operate off grid with a battery system, clouds are not really an issue you think about much. Over the course of the year, you're going to produce that 1,400 kilowatt hours per kilowatt of installed. Now, I made a choice of a metal roof when I built the house for long life, hail resistance, and reflectivity, and that made my solar installation so easy that even I could do it. For metal roofs, there's a clamp that bites onto the seam. It doesn't penetrate the roof material, and then the rails mount to those clamps, and then my microinverters are mounted to the rails, and then the panels lay right over the top. So I have a zero penetration, roof penetration installation. I actually ran the conduit right over the edge here, down the side of the wall, and my electric panel is on that, my outdoor panel is on that side of the house. So I have no holes in my roof. So a metal roof was a great choice 24 years ago when I put the system on. So now I'm going to get a little, this is a little complex, but I want to show you how it's pretty interesting how your utility policy can really affect the payback and value of your system. I mentioned that there were no carryover credits when I installed, no, if I produced extra, I gave it away for free. My utility changed their policy, and in January of this year, they started allowing banking unlimited carryover hours. It didn't expire. Then they had another policy change in the mid-year where instead of just one fixed rate plan of 11 cents a kilowatt hour, they offered a variety of plans, including one of free nights and weekends. Now, as you can probably tell, I'm a big data guy. I've got more data on my electric use and solar use and everything than probably anybody in the world. And I knew exactly my hourly energy use. And so I ran some pivot tables, looked at this plan, and I thought, oh my gosh, this matches beautifully with my solar production. I may never have another electric bill again. And that is turning out to be the case. So there's a lot of stuff on here. I'm going to step you through this here. Make sure, yeah, we're good on time. I'm getting close to the end. So here are my billing. I'm billed at roughly the middle of the month. So 1/14, 2/14, 3/14. That's the period that my billing period ends. Right here's my total net kilowatt hour from the utility. And then when we went to the day and night plan, I broke out a couple of columns here for the last 2 months. This is my electric cost, and there's a base fee, and then there's some taxes and stuff like that. So let me show you. In January, February, March, and April, I was using net energy from the grid. My solar was producing, but that's winter, doesn't produce as much. So I was using a little bit of energy from the grid. And you can see I had an electric cost. I had $27, $35, $14, $10. They have a little power factor cost. Here's my base fee. So for the month, my electric bill was this amount. The energy portion was that amount. Then in May, the May billing period, I started generating extra. I actually banked 77 kilowatt hours. So I had a zero energy cost, just the base fee. My utility charged a $5 penalty if I didn't use at least 100 kilowatt hours. So I paid $24.40 for that month, and then the next month, and then the next month. I used some of my bank, but I was still going. Now I switched to the new plan, and I'm banking energy. I'm actually during the day, in July and August, the two hottest months of the year where the air conditioner is running, I ended up with net banks of energy, and I used all my energy only at night and on the weekends. So my bill, when they went to this plan, they changed the base fee to the $23. So I don't have that $5. It's basically rolled in. So my utility bills every month are probably going to be $24.40 from here on out, because I'm banking enough that I'll bank more this month, bank more the next month. That'll ride me through the winter. So what's interesting is the size of my solar system is now almost perfect. My wife only charges her electric vehicle at night, so that's free, because our daytime rate is now 16 cents a kilowatt hour. But the beauty is that's what I'm banking my solar production at, 16 cents a kilowatt hour. So that plan, like I said, unless you know your energy use and you know it's going to work for you, I have a very well insulated house. I can air condition it at night. It will ride through about half of the day and stay comfortable. So for me, it works perfectly.
We had a question come in. Who is your utility?
I'm at Grayson Collin Co-op is my utility. They serve most of Grayson County and probably roughly the northern half of Collin County, and maybe just a little bit. I'm not sure if they're over into Hunt but it's an old municipal co-op from the days from the late 30s, I guess, when co-ops came about. So this is just to show you the efficiency of my house and kind of summarize this. This is kBTU per square foot per year. BTUs are an energy, you can convert kilowatt hours. A typical Texas house is around 41 kBTU per square foot per year. And that's other energy, water heating, cooling. My house only needs 7 kBTU per square foot per year. So remember, that's my efficiency that I did. My renewable energy system produces 5.8 of that. So I have a lower footprint and I produce most of it with a fairly small solar array. There's some other benefits to solar as well. So the kilowatt hour price is now less than half of my utility costs. System pays for itself in less than a decade, and then it generates free electricity basically for at least another decade. Solar is the lowest carbon content electricity and no air pollution. Efficiency is number one. Remember, if you don't need any energy, that's the greenest of all choices. But then when you do need energy, solar is probably the best one out there. Uses no water, it's silent, no moving parts. Distributed solar actually reduces the peak load on the grid. I argued with my co-op when we were first doing this, the value of my system. I said, look, in the peak, when you're trying to feed electrons to all these houses running air conditioners, I'm generating solar, and so I'm not drawing very much. So I'm actually saving your grid from being peak loaded. And so all of us do that. And so there's value in that to you, and I hope you recognize it. And eventually, I think they have. Local generation means less energy loss. You know, you lose about 9% of the energy content coming out of the power plant just in losses in the grid, right? I mean, there's resistance in the wires. So when I'm producing locally, I don't have those losses. And when I'm feeding a little to my neighbor, there's very little loss going right across the street. No moving parts, I mentioned, and I mentioned the property tax exempt in Texas. If you want to read some more about efficiency, I wrote this book about a year ago. It's called The Joy of Efficiency, and it's available on Amazon, and the link is on my website. You can just Google it, type in here. I've got all the details on my house efficiency, the solar system, and even the industrial efficiency that we did at Texas Instruments, commercial and industrial. So it's all in one convenient book. If you want to grab that and read some more. And then I have a bunch of links on here toward the end. I'll just briefly talk through those since we still have time. North Texas Renewable Energy Group is a great organization, nonprofit group here in North Texas. They have a monthly meeting. They're now online instead of in person, but covering a variety of topics on solar and efficiency and just all sorts of good stuff. It's a great group of people. There's really an expert in that group for almost everything, electric vehicles, whatever you want to know about. Somebody in there knows more than you and is happy to share. That's what I love about that organization. Texas Solar Energy Society is here. We just finished last weekend the DFW Solar Tour every October. Some of us open up our houses for what used to be in-person tours. This year we did online, but the good thing is you can go click there. We all did videos this year and had a Zoom Q&A. You can go look at the videos of the houses and sites, which are now on YouTube perpetually, I guess. So here's the link if you want to go look at my house details. It's energized.com/house. You could probably Google Westbrook house and it will come up. Right near the top, I have a PDF link of this presentation. You can download and then have all the links there. Solar United Neighbors is, there are groups who will get together. If a lot of neighbors are interested, they will use their group purchasing power to get a cheaper price. So, you know, if I'm a solar installer, instead of me having to market to every single house, if somebody calls and says, hey, there are 8 of us who are interested, they come and market once, reduces their cost. If they win, they get to do all 8 homes, and so they pass some of that savings on to the neighbors. And there's another site with Go Solar Texas with some good resources in there as well. So that's my last slide. So now we'll pop over to the question and answer.
There was a question that came in. Does PVP known to have diminished performance over the years? The performance in year 15 is a fraction of performance in year 1. Is there any guarantee of performance over 20 years?
So yes, your point is valid. On average, solar panels degrade roughly 0.5% per year. That's quite variable, but that gives you a ballpark. And I've seen that in my own. In my 12 years, I can look at my annual graph and it's sliding down just a little bit. So the beauty of it is I've actually been getting more efficient. You know, as we've replaced an appliance or as we've replaced this, I continue to improve efficiency faster than my system is degrading. So, that's it. Now, when you get a bid you will often see warranty or guarantee on the panels. And there will be often two different numbers. There'll be like labor and workmanship. So if the panel just flat out fails, that has a duration 10, 15, 20 years. It varies depending on the supplier. And then often you'll see where they guarantee performance. It will guarantee some level, 70% by this year or something like that. Not as common, but ask for those numbers. But in general, panels, certainly if you're doing the monocrystalline panels, they're well understood on their degradation. Okay, let's see.
Paul, there was a question about insurance. What about insurance on a system? How easily can damage occur? And what if a roof needs repair, replacing underneath system? And then there was another question about hail damage.
Okay, so yeah, insurance, your mileage will vary by insurance company. So let me just throw that one out. In general, solar panels are insurable just like anything else. You could actually argue they protect the roof. And I have some photos from the tornado that came through Dallas and Richardson of a couple of roofs ripped off. And then right next to them was a roof that was half ripped off. And the piece that was still there was the part that had solar PV on it, because that racking and railing provided additional rigidity to that structure and saved it during the storm. And almost all the panels were undamaged, which was pretty interesting. A couple of them had been hit by debris and broken, but they are insurable like anything else. All solar panels have to be tested. It's a 1-inch steel ball shot at, I think, 52 miles per hour. They have to resist that. So we've had golf ball size is about the biggest hail I've seen, maybe just a hair under golf ball here. I've had no damage to my panels. And in general, you've got to get up closer to baseball before they'll start shattering the polycarbonate covering on there. So they're fine. I'm pretty sure if you get an installer, ask them that if you need to re-roof, will they come and remove the panels and then reinstall them? There are various guarantees on that. It's going to be installer specific. With my metal roof, it's interesting. My metal roof is class 4 hail resistant. I get a 20% discount on my homeowner's insurance, have for 23 years now, for having a metal roof. And actually the solar panels are now protecting part of my metal roof from, even getting hail themselves. So cascading system there. Okay, I think we got that one. Let's see.
There was one that came in. Can you comment on community solar versus solar PV on your home?
So community solar is, say you live in an apartment or a condo that doesn't allow you to put them on, or maybe you have a HOA that's more than, although they're not supposed to prohibit them anymore. If you can't really install it on your roof, maybe you're really shaded, you have a lovely wooded home site, there are community solar are when a system is installed at a sunny field somewhere, maybe a farmer, leases a piece of his land, and people buy into that. So you buy into a portion of the production. I haven't done it. I don't know the details on how all the legal aspects work, but it has been done. And maybe some of those links in there, I just haven't dug around on community solar, but it can be a way for people who don't have the ability to install it on their own residence to buy into solar.
And then when the solar panels are no longer usable, how do you dispose of them? Can they be recycled?
So that's going to become, becoming a bigger problem, but as often is the case with ingenuity, as things become a problem, somebody comes up with a solution. And there are several companies I know around the world working on reclaiming the solar panels at the end of life. They're silicon based, so they're just the raw panel is silicon. And in fact, this is interesting. Waste silicon from semiconductor, because semiconductors are built on silicon wafers as well. Scrap wafers are often sold to reprocessing companies, which then sell them as feedstock to solar panel manufacturers. So there's an upcycle almost from that side. Well, now the reverse, you've got a silicon based panel with some metal, and there are ways to separate those components and recover. I think like anything, we're often lazy until the need is really great and about doing those things. But I have good hope that we will solve that, and panels will be manufactured in more friendly ways that they can be recycled and recovered at the end. It is an issue. It's nowhere near an issue that a coal plant dumping mercury into your lake and the other things associated with fossil fuels. So people will talk about the negatives without comparing the negatives of the existing system, which are still far greater. I see a question. I'll just read it here and answer. Typical grid-tied inverters will not operate during an outage. If you isolate from the grid and use a separate clocking inverter, can any of the inverters back up and match the load? So question, most of us are grid-tied, and because of safety, if the grid shuts down, my solar system inverters have to shut down, and they won't come back on until 5 minutes after the grid is back on. That's so you don't electrocute a lineman who thinks he's safed out a system and you're backfeeding into him with your solar panel. So that's the downside of being just grid tied with no batteries, is when the grid goes down, if it's sunny, I can't produce. Now, there are ways around that. You can use, if you have a string inverter and a battery system, and you can disconnect from the grid and do a standalone. It's called islanding. You're an island. Islanding is a way that can be done. Microinverters had no way to do this, but the newest generation that's coming out can actually island and form microgrid on your house and continue to produce. And now with like Tesla Powerwalls and other battery technologies coming on, they're starting to, it's still a little unclear and a little murky right now, but people are starting to figure out how to make that all work together. But as of right now, the downside is if the grid is down, my solar is off. Now, fortunately, our grid has been very reliable, but that's the way it works. But it can be overcome with islanding. Let's see. Yeah, here's a question. I have a lot of mature oak trees covering most of my roof. Are solar panels for me? Probably not. If you have like a large backyard area, that's more open, or a field or space, you can do a ground mounted system out in the lawn. But yeah, solar, you're going to have limitations on some homes. I have 2 acres of heavily wooded property, but I have a 2-story house. And so right where the house is, if you get on the 2nd floor, I only get shading just in the first hour and the last hour of the day on the panels. So I'm a little bit shaded, but most of the peak hours of the day, I'm in full sun.
We have a question about, do you have any comments on battery storage, or about the advantages for EV owners to having solar PV?
So battery storage, there's a couple of, let's take general batteries, and then we'll talk about batteries in an EV real quick. General batteries, there can be an advantage if you can island, then you can operate offline. Or if there's a big power outage, all your neighbors can come over to your house and use your energy. You'd be most popular in the neighborhood. Batteries are good. And then, thinking about my rate plan, look at my nights and weekends plan. I could charge the battery overnight and use the energy during the day, kind of like a solar system. So I could, I don't want to say game, but I could work the rate plan to my advantage with a battery system. Now, an electric vehicle is a giant battery that you use to drive around and then often just sits in your garage. In Japan, they have bidirectional chargers. The US has not progressed yet as far as some countries, where you could use your EV as a bidirectional battery. So you could charge it overnight, and if you're not driving anywhere during the day and it's peak hours for energy use, you could draw off your EV battery, just like any other battery. Unfortunately, that's not been implemented in many places in the US yet, but it's certainly doable. It's been done and it can be done. We just haven't done it.
Paul, thank you so much. We've come to the end of our time. And thank you. It was a great presentation. And I do want to end on with a little more positive news about solar, and that is Rocky Mountain Institute posted on their Facebook page today that the company New Era has that does solar and renewable energy has a larger market capitalization now than Exxon. So that is great news. Solar and renewable is here to stay. And so with that, we will sign off and look forward to seeing you next week. Bye-bye.
Bye-bye, everybody.